Alright, this is a demo of my Helix programming system. It allows me to version program state, so I can go forward and backwards while a program is running, and actually even branch it. It's just using regular Git. The way I can do this is by exporting the program state and just storing it as a plain YAML file. Actually, the syntax of the language is just on top of YAML. So what you're looking at right now is a simple program here. This is the main function. This is Lisp style S expression syntax, if you're familiar with that. The first element of each of these arrays is just the function, and the rest of them is the argument that the function will be called on. So this function step is being called on this, I call them micro VMs. So we're calling step on this cell VM. So I'm going to go ahead and run this debug wrapper here. So we can start stepping through the program. Unfortunately, this does not preserve white space. And you're going to see on the left here is a log tree that's going to unfold as we step through this. But right now you can see that it's this is where our program counter is. The program counter is just the top of this frame stack frame, and you can see this cell VM here has already started running. The status is running, and it's already has this frame, so that means it's ready to execute this point here. So how this whole thing is working is actually a Python script grabs this entire file and just uses Helix itself, calls the step function from within Helix on this whole file. So this Python basically creates a Helix program that looks like this, and it just runs this Helix program, and Helix prints out the new state of this inner VM, and then Python just writes it back to the file. So that's all that's happening here. Okay, and so I can continue stepping through this, and something's about to happen. So you can see that we created an error here. We can go backwards and see that this is the line that caused the error. And Helix actually has first class errors, just in the same way that like some languages can have first class types or whatever. So that just means that they can be represented as data, just like everything is, because how else am I supposed to do this procedural versioned machine state? Anyway, so we can go back up here and take a look. This is actually a bug in this Python wrapper, but you can see that it created a branch here mistakenly. These are the same. I can Alright, well, I'm not sure what's happening there, but anyway, so we can see this VM state. So we want to stop this from happening, so we can go back to before it happened, and the issue is that we didn't call set with enough parameters. So if I just put total here, and we'll be setting the variable to total, and this should create an automatic branch. Yep, so we've continued running from where we were, having fixed that error. And you can see that we've set total to something, so the variable total has appeared down here, and then we're going to set total to a new thing, which is x plus y, so that's 13, and then add y to the total, okay, and then it's just some demonstration of being able to access inner values just using dot syntax. And Helix also has includes, so at the beginning when the program starts, it looks for this include folder, and it will include all the stuff in here, and this actually even works with .so files for precompiled binary C++ If I need to put an extension on this, I can show you that in a second. And so as you can see, we already stepped the cell VM twice, but it does have more happening in its main function. So this frame state, stack frame, excuse me, is pointing here right now. And so it's about to execute this, and then once we get to the end of this outer program, we're going to call start, which is basically just the same as continue in a typical debugger, and that's going to finish off this inner VM and as well as the outer VM, because it's that's the last step. So they're both finished now. Okay, and let me see if I can quickly demonstrate the library importing feature. So in this case, I've actually pre-compiled this library, and if I run Helix on this file, it should open this very simple SFML thing, but this is using these SFML functions have been imported from this SO file. Alright, that's it. Hopefully that's given you a taste of some interesting functionality that I'm working on, and this is all available on GitHub if you want to check it out. Thanks.